no one has ever given me an objective definition of a weed. Every single definition I have ever heard from anybody anywhere in the world is purely subjective. So I'm going to ask the question, is there even such a thing as a weed?
Welcome to the 277th installment of Ear to the Ground, the Land Stewardship Project's podcast on family farming, regenerative agriculture, regional food systems, and local democracy. I'm Brian DeVore, editor of the Land Stewardship Letter. When one abides by the farming philosophy that everything is connected to everything else, the logical next step is to start asking questions like, do weeds really exist? Or, more specifically, are we spending too much time and effort eliminating them and not taking into consideration the role they play in an agroecological system? Alan Williams says questioning the status quo is key to developing farming and ranching systems that work in cooperation with nature, rather than against it. He approaches such questioning as someone with a varied and deep background in agriculture. Besides being a sixth-generation family farmer and founding partner of Grass-Fed Insights, Understanding Ag, and the Soil Health Academy, Williams holds a doctorate in livestock genetics. He describes himself as a recovering academic, and in fact feels that when it comes to regenerative agriculture and soil health, the scientific community has been behind the eight ball. It's innovative farmers who have led and continue to lead the way on farming in nature's image, says Williams. Those innovators do that by, of course, asking lots of questions. By working with such curious agrarians, Alan has seen firsthand the positive results that can come from a regenerative approach. He's consulted with more than 4,000 farmers and ranchers in the U.S., Canada, Mexico, South America, and other countries, on operations ranging from a few acres to over 1 million acres in size. In 2022, LSP invited Dr. Williams to Minnesota to talk to farmers about ways of using soil health and regenerative agriculture to bring the land back to life practically and profitably. As part of this event, we've launched a 4-part podcast series featuring conversations with Williams. In episode number 276, Alan talked about the principles of regenerative agriculture and the barriers that stand in the way of more farmers utilizing this system. This episode will describe what he says is a critical element of a regenerative system, learning how to adhere to the 3 rules of adaptive stewardship. Alan started our conversation by describing the first rule of adaptive stewardship, the rule of compounding cascading effects.
First of all, I'll say this, the 3 rules of adaptive stewardship, we developed these after many years of observations and outcomes and so forth. So these were things that just made sense to us as we started looking at the developments along the journey of regenerative agriculture. And so the 3 rules of adaptive stewardship, the very first one is the rule of compounding. And basically that means that in nature and in biology and in life in general, there never are any singular effects. Everything that happens creates a series of compounding, cascading effects. And these effects are never neutral. They're either positive or they're negative. So the real question we have to ask ourselves is not whether we are creating compounding and cascading effects. We are. Whether we make a decision or not, whether we do something or don't, we're creating compounding, cascading effects. And we have to realize because they're never neutral, we're either intentionally or unintentionally creating either positive or negative compounding effects. And so this means that we have to be intentional, even intentional every day, in the way that we think about our management decisions and the things that we're going to do on our farms or ranches. Because again, make no mistake about it, everything that happens is going to be compounding in nature, and we want to make those compounding effects as positive as much of the time as possible. This also bleeds over into epigenetic effects for our livestock, for our plants, our crops, for our microbes, and ultimately for us. And just like all of the other biological effects are compounding in nature, so are epigenetic effects. And these epigenetic effects also are never neutral. They're either positive or negative. Epigenetics is the influence of environmental factors, and that can be anything from nutrition to injury to disease to climate, whatever the case may be, but the influence of environmental factors on degree of gene expression in an individual. And let's think about gene expression like this. Imagine you have a light switch on your wall, and that light switch also has a dimmer control on it. So genes, any pair of genes that codes for any trait can express themselves anywhere from very little to a lot, or anywhere in between. It's a gradient in terms of their degree of expression in our bodies or in our crops or anything that has DNA. So it's sort of like that light switch. I can either turn my lights all the way on or all the way off, right? But if I have a dimmer switch, I can control the degree of light that I'm getting. And that's basically what epigenetic factors do. Genetically, they control the degree or magnitude of light that you're getting from gene expression at any point in time.
Can you give me an example of the compounding cascading effect where somebody might see that?
So let's think about grazing, and I'll give you two different examples here from grazing impact. So the first would be this, and this will be an example of negative compounding. So right now, most of the country is in a heat wave. You know, we are very, very hot, and we're going to be down here in the deep south. We're going to be in the hundreds all week, real temp for our temps, and then somewhere in the 120s plus for heat index. And we've been a little dry. So if I go out and I overgraze right now, and I allow my livestock to graze my pastures down tight, then I'm going to create a whole host of negative compounding effects. And there's literally hundreds, but I'll give you just a handful of the most important ones. So if I allow them to graze down tight, then my soil temperature, because I've removed the shading from the soil, from that plant leaf material, my soil temperature is going to heat up dramatically. And if I've got daytime temperatures in the mid to high 90s or even the low 100s, then my soil surface temperature is going to reach 150 to 160 degrees or more. That's going to immediately wick any moisture, evaporate any moisture in the top several inches of my soil out. So I'm going to lose my moisture. Then that soil heating up like that is going to do significant damage to the soil microbes. So that's already two negative compounding effects occurring. A third is that I'm going to have significant root die-off. So now that plant is going to struggle to recover because 50+% of its roots have now died off, and it's under stress because of the heat and the dry. Then, because I've removed a majority of the plant leaf material, I'm not going to have near the photosynthetic capture that I could have had. So now I've got 4+ different negative compounding effects. Basically, because it's now turned off hot and dry and I overgrazed my pasture, I'm likely done on that pasture for any reasonable regrowth for probably the rest of the year. So now I've got a negative compounding effect relative to biomass production and livestock performance and even available forages to graze. I'm going to have a collapse of my soil aggregate because my soil bacteria looking for carbon to consume that they have to have, they're going to overconsume what's there now because of my overgrazing. And that includes consuming the biotic glues that aggregated my soil and allowed for water infiltration. So now my soil is going to collapse on itself. I've lost my nutrient cycling because of the loss of those mycorrhizal fungi colonization. And now I desperately need a rain, but if I do get that rain, because my aggregates have collapsed and my soil has become immediately compacted and crusted, I'm going to capture far less of that rainfall that I so desperately need. And we could go on, but you get the picture here of what's occurring in terms of negative compounding. And so they're immediate, they're intermediate, and they're long-term. We just impacted the immediate, we just impacted the next several months, and we just impacted next year as well, with that negative compounding effect. Now, if we reverse that, to give an example of positive compounding, and I don't allow them to take more than 30 to 50% of the total plant leaf material in that graze. I leave plenty of leaf material for photosynthetic capture after the grazing event. I've left plenty of leaf material to continue to shade my soil and protect the soil moisture and soil temperature. I also have far less root die-off or root growth stoppage because I've protected that as well by leaving plenty of above ground shoot biomass. So now I get much quicker regrowth. I haven't stopped my nutrient cycling. I haven't stopped my water cycling. I'm going to be able to get additional grazings off of that this year yet that are going to be beneficial to me. And I'm not going to have the collapse of my soil aggregate and inability to capture water. So the next rainfall I get, I'm going to benefit versus the neighbor that overgrazed. So those are two opposite examples of negative and positive compounding effects. Number 2 rule is a rule of diversity. And this is really very important. If we want to make significant regenerative progress, then building diversity in our ecosystems is critically important. And a lot of people think about diversity just in terms of our plant species out there, and that's important. And I'm going to talk about that. But we're also talking about diversity in a whole host of other things. So we're talking about diversity in our plant species and functional groups. We're talking about diversity in the microbial species that are underneath the soil surface. And we're talking about diversity in insects, birds, and animals, even the types of livestock that we're running out there. That's why I like to have multiple types of livestock and not just a single species of livestock. I actually derive significant benefits from that contribute to the first rule, positive compounding effects. And so the first things we look at in order to build diversity in everything else, I've got to first focus on building diversity in my plant species. That's how we build diversity in microbial species, insects, birds, and so forth. So I want diversity in 2 different ways in my plant species. I want a lot of different species out there, like a lot of different types of grasses, legumes, forbs, broadleaves, and so forth. But I also want diversity in functional plant class group. And the 4 primary ones that we deal with every day in terms of functional groups are grasses, legumes, forbs, or broadleaves, whatever term you want to use, and then our woody and brushy species. And frankly, I always want to have all 4 of these represented in my pastures because they all 4 combined bring significant benefits. And if we look at a native prairie or grassland, then they were always comprised of all 4 of those functional groups. Now, why do we want diversity? Well, there's a multitude of reasons. Number 1, it helps to create positive compounding and cascading effects. So there we go back to our first rule of compounding. Number 2, we get a whole array of plant phytonutrients that we do not get otherwise. The work of Dr. Fred Provenza and others, out of Fred's 40 plus years of work, he has shown the incredible value of what he calls these plant secondary and tertiary compounds, these phytonutrients that are actually not only nutritional in value, but also medicinal and anti-parasitic. So we can, with diversity, our livestock can self-medicate every day and they can self-deworm every day. So that's another reason for diversity. And then if we see diversity in plant species and functional groups, we see a much, much broader diversity in the soil microbial species that are working for us underneath the soil every day. And we see much broader diversity in beneficial insects and pollinators and bird species. So that's what we're looking for. And one of these functional groups that we often tend to view with derision, and disdain is this forbs or broadleaves functional group. And we commonly call those plants weeds. Now, I will tell you that every single time I speak, and I do this anywhere I speak in the world, I ask the audience to define a weed. And I do that very purposefully. And we can major in weed science in college. We have weed science textbooks, weed science professionals, weed science extension specialists, right? But no one has ever given me an objective definition of a weed. Every single definition I have ever heard from anybody anywhere in the world, including weed scientists, is purely subjective. So I'm going to ask the question, is there even such a thing as a weed? Or is that actually a misnomer? Because every plant that is growing there purposefully. And every plant has nutritional, medicinal benefits that can be huge in our livestock operations. And our livestock will actually eat a far, far greater variety of these plants we call weeds than we would imagine. And we have witnessed this over and over. So what we teach people now is whenever you see a plant growing there that you may call a weed, whether it's a thistle, pigweed, ragweed, dog fennel, milkweed, whatever it may be growing there, the first thing you have to ask yourself is, what is nature telling me? Because make no mistake about it, that plant is growing there not erratically, not randomly, but very purposefully, because out of all the different plants in the soil seed bank that could have grown at that particular point in time, it's always certain ones that are growing. And there are 3 really good books that I'll mention that help people to be able to understand the value of these plants that we call weeds and why they're actually growing there. And they are Weeds and What They Tell Us. The second one is Weeds, Guardians of the Soil. And the third is Weeds, Control Without Poisons. Diversity is key. And in our management, especially our grazing management, we manage for diversity and never sweat the weeds.
I'm struck at how polar opposite that is from the conventional farming system that we're so used to, with where it's the goal is the less diversity, the better. The idea is we're trying to get rid of any competition for those row crops, those monocrops that we're putting in. I can see why maybe people resist a little bit because it is so polar opposite. It's not just a little tweak.
So you're exactly right. And we've been trained to think that way as well, right? A couple of things here that are really important. First of all, if a plant that we call a weed is growing there, again, it's growing there purposefully to try to heal something, and it's healing something that we caused. Okay, so that's what we have to remember. We are the cause of that plant growing there, not anybody else, not anything else. It's us. And so we have to ask ourselves again, what did we do that's allowing that particular plant to dominate at this point in time? And one of the other things that we do quite often is when we go into somebody's pasture or even row crop field or wherever, and there are, again, these plants that we call weeds growing there, we'll take our shovel, our spade, and we will go dig immediately around that plant and its roots. And inevitably, what you find pretty much every single time is a much healthier soil right around the roots of that particular plant we're calling a weed. So it's doing its job. It's healing the soil. And that's evidenced every time we dig around them. And if we look at their nutritional value for livestock, I'll give you 2 or 3 quick examples here. Pigweed, for instance, typically will average about 25% crude protein and about 73% in vitro dry matter digestibility. That's a pretty good feed. Common ragweed, again, 25% crude protein, 73% in vitro dry matter digestibility. So the same as pigweed. If we look at something like curly dot, it's 30% crude protein, 73% in vitro dry matter digestibility. And we could go on, but the bottom line is they're pretty darn nutritious.
Yeah, I can verify that. I was on a farm in southeast Minnesota last summer where they were doing adaptive grazing of ragweed, and they did a Brix reading right there and got a really pretty respectable reading off of that. It was pretty impressive.
Exactly.
So that brings us to the third rule here.
So the third rule is the rule of disruption. Now, this rule is also very, very important. And unfortunately, it is one of the most ignored rules. As a matter of fact, most of us in our practices on our farms are exactly the opposite. We're highly prescriptive, right? Highly formulaic. We're following a recipe. And the rule of disruption says, don't do that. It's not prescriptive. It's not formulaic. It's not a recipe. And so with the rule of disruption, what we have found is that nature has tremendous resilience and actually responds quite well to challenges. So if we can introduce planned, purposeful disruptions, then we can create a host of very positive compounding effects. So now we're back to rule one again, right? Those positive compounding effects. And I like to illustrate it to people this way so that they can sort of grasp it. With the rule of disruption, if we think about a human athlete, to be an elite athlete, if you do the same exercise routine at the same duration and intensity over and over, you will never reach elite status. As a matter of fact, what will happen is you will hit a wall, you'll stagnate, and then you'll actually start going backwards. You can't even maintain the same level of athletic performance. So every athlete knows that to be able to continue to make progress as an athlete, they've got to introduce planned, purposeful disruptions into their exercise routine. And therefore, that's what we have to do out here in our fields and our pastures on our farm. So how do we do that? Well, first of all, we have to understand what I call the concept of anti-fragility. Okay. And so that just means that, the opposite of being fragile, right? Gaining from disorder. Nature and biology, just like that human athlete, nature and biology benefit from what I might call shocks to their system or acute stressors. And acute is very different than chronic. Acute means short term, and acute almost always benefits. Chronic will kill. So acute builds, chronic kills. So that's what we want to understand. And prescriptive systems are weakened and even killed oftentimes. So we need systems where we introduce this disruption or this disorder. So first of all, we have to think in terms of not doing things the same way every time and realize that adaptive and regenerative management is not a recipe, a routine, or a formula. So we have to get away from that. So then very specifically, how can we be disruptive? So let's talk about grazing. Okay, what are some ways to be disruptive in our grazing? Well, first, alter stock densities. I call this pulsing of stock density. Too often, what we see is that when someone adopts what they may call adaptive grazing or mob grazing, as others may call it, they will pick a stock density or a narrow range of stock densities, and every time they'll utilize that same or similar stock density. Well, initially, when you increase stock density, it was a disruption. But if you use it over and over, now it's no longer a disruption. It is a recipe. It is a prescription. And now you're going to become non-adaptive and non-regenerative. Another disruption is moving through your grazing rotations in a different pattern each year. Oftentimes, especially in the northern climes, people have their cattle up or their other livestock up for the winter, whether it's in barns or whether it's in, a sacrifice paddock or whatever. And then when the spring flush comes, they start grazing them through their rotations for the rest of the grazing season. And every spring, they start in the same pasture and move through the same rotational pattern. Stop it. If you've been starting in pasture A every year, start in pasture D next year instead of pasture A. So altering your rotation patterns is another really good disruption. Alter grazing heights on and off. Now, this is very difficult for a lot of grazers because they've been taught, especially if they're a mid grazer, to go on at the same height and come off at the same height, and to always keep those pastures as vegetative as possible. You're never going to make progress that way, and you're never going to increase diversity out there, and you're going to start creating negative compounding effects. That will cause you to hit a wall after a handful of years, and you'll wonder why. Another one is alter rest periods. So again, many mid grazers and many dairy grazers and others, this is a challenge for them because they're so used to coming back to a previously grazed paddock, every 21 days, every 30 days, every 40 days, whatever the case may be. And you keep doing that over and over. If you want to improve and create very positive compounding effects and increase diversity, you must alter rest periods. You can't have the same rest period. If you're like another one is alter species order. So if you're like us and you have multiple species of livestock, then from time to time, alter their order as you move them through the paddocks. For instance, if I have cattle and sheep and say pastured chickens, then I may move my sheep through, then my cattle, then my chickens. Another time, I may move the cattle through first, then the sheep, then the chickens. So I can alter species order. Another one is alter time of season or time of year that a paddock is grazed. This, again, can produce very positive compounding and cascading effects. Another one is alter the total number of days that a paddock is grazed in any given year. Another one is alter paddock configuration. And I'll give you a perfect example of this. So if my desire is to get a high degree of trample and a lot of even manure and urine distribution to tap the latent seed bank and increase plant species diversity, then I want a long, narrow paddock, not a square paddock. I can have the same stock density and the same acres underneath that paddock fenced in. But if it's square versus long and narrow, I'm going to get two very different results on that grazing event. So paddock configuration is important. Alter paddock direction. So if my paddocks have generally year after year been running north and south, then next year I'm going to have them change to oriented east to west. So just altering paddock direction can make a big difference. Plan burns can be another one, and leader follower. I'll give you an example of that. So we do a lot of grass finishing. So oftentimes we'll move the finishing herd first into a new paddock and immediately follow them with our main mob that's made up of cows, calves, yearlings, and so forth. That's a leader follower. I can also do a leader follower by grazing sheep, then cattle, or the opposite. I can do a leader follower by grazing cattle, followed with chickens or pastured pigs. And we can actually have multiple combinations or iterations of these grazing disruptions. So I can combine 2, 3, 4, or even 5 of these disruptions all into a single disruption. So I've actually added it up, and there's more than 100 different possible grazing disruptions with the various iterations that we can use to continuously make progress. So that is the rule of disruption.
What really strikes me about that is observation and close monitoring is just critical to that rule.
Yes. You do not want to just walk away and leave them when you do many of these. You want to observe, because your observations are going to determine how long you leave them in a paddock, before you move them to the next paddock, and those types of things, and even how long of a rest period to give, when to come back for the next grazing event, so on and so forth.
The next episode in this series will feature case studies of farms and ranches that have successfully made regenerative practices a critical part of their daily operation. As we're recording this series, Dr. Williams is scheduled to be in southeastern Minnesota for a set of Land Stewardship Project Field Days, August 17th and 18th, 2022. For details on these events and resources related to Alan's work, see the links on the podcast page for episode number 277 at landstewardshipproject.org. If you have comments or suggestions about this podcast, contact Brian DeVore at bdevore@landstewardshipproject.org, or you can call 612-816-9342. By the way, it helps us greatly if you can give Ear to the Ground a rating on iTunes, Stitcher, or whatever podcast platform you utilize. Thanks to Laura Morgendale, Western Minnesota musician, for Ear to the Ground's theme music. And a special thank you to all of Land Stewardship Project's members who make initiatives such as this podcast possible. If you're not a member, visit landstewardshipproject.org to learn how you can support LSP. Thanks for listening.